So common and natural logs today, you may remember a little bit from last year, now that you've had time to think about it. We are going to start off with just a little bit of reviewing our vocabulary so far. We have talked many times about logarithm just means exponent. So if you have it in exponential form, the 4 is the exponent. The log is the exponent. If you have it in logarithmic form where it says the log base 3 equals 4, the log is 4. So the log is 4, the exponent is 4. Vocabulary word that we do not use much here at our school, anti-logarithm. I'll just remind you so that if you come across it, anti-log is just the argument of a logarithmic function. So it's just the 81, or the answer you get when you take something to a power. We do want to be a little bit careful with this vocabulary today so that we do exactly what the problems ask us to do. Power is a base raised to an exponent. So we're going to have problems that say, write this number as a power of 10. That means we need to actually write down that the number equals 10 to the something. It does not mean just what is the exponent. When it says write it as a power with a base of something or other, that means write it with the base to the exponent, write out the whole thing. Common log is going to mean our base is 10. If we don't write a base in at all, it means the base is 10. We have to be a little bit careful with this notation on the Inspire calculators, because when you push the log button, you automatically get that little box for the base. And if you just push log and then you start typing a number, it's going to put that number in the little box for the base. So if you are trying to do a common log, you have to remember to skip over that base. Just use your right arrow to go to the other box for the argument. Natural log is going to be a log that has a base of e. So it is going to be log base e of x, we write as the natural log of x. We know that logs and exponentials cancel out. So if I have log base e of e, those are inverses, so I'm just going to have 2. So this statement here, I'll erase that back so you can still read it a little bit better. Natural, when we have e to something and we want the inverse for that, we'll take the natural log in order for those to cancel out. So far, so good with everybody. Now I want to also caution you on tests. When I put the Inspires in press to test mode, that means you only have access to common and natural logs on your calculators. You can't do log base 7 of something. So those kinds of problems, you're supposed to be doing work to where you do it without the calculator. Don't get yourself dependent on the homework, on being able to punch it in to make sure what you're writing down is really the right answer. Make sure you're confident and can do those as no calculator problems, because you can't do log base 7 on tests in this class. Okay, looks like everybody's gotten that written down. So these are some of the kinds of problems that we are going to be working on. And so write 24 as a power with a base of 10. This is what I was talking about, why we wanted to be clear on that vocabulary. That means write 24 as a power that has a base of 10. So that means 10 to some power. How can I figure out what x is? When I've got 10 to a power, what's my inverse so I can get rid of that and have just the x? Okay, I'm going to take the log of both sides, common log, log base 10. And if I do that, log base 10 of 10 cancels out, and you guys help me out here. You're the ones with the calculators. X is, and you know where to find that on your calculator, Control, and then the 10 to the X button, so you get the LOG, the arrow to go past the little box for the base, and then just put in the 24. Good. See hands popping up. Anna, what do you have? And here you have to be careful that you've read the directions. It didn't say what would the exponent have to be. It said write this number as a power of 10. So you actually have to write 24 equals 10 to the 1.380 for your answer. Questions for that? Nice and easy lesson today. Okay, what about writing 24 as a power with a base of e? Well, we start off the very same way. It's still 24 equals, but instead of 10 to something, e to something. How am I going to figure out, what do I have to put in the calculator this time around? Morgan? We're going to take the natural log of both sides, because natural log will serve as the inverse, and we'll just have x there. So what is ln, natural log of 24? If you look here, control ln, so your e to the x button. Jack, what'd you get? So then we need to say 24 is e to the 3.178. Make sense to everybody? Okay, let's then move on to the problems you're going to love when you see these in the problem sets. You're going to love them because they're just such a challenge and make you think so very, very much. What do you have to do? What? What do you have to do on these? Just punch it in the calculator. Go ahead and do that super fast, both of those. Am I right? You're going to love it when you get to these. Don't really have to think much. Who's got it? Aiden, what's the first one? And what about second one, Gina? All right, I think we're good with that. And last example of today's lesson. This is how short the lesson's going to be. 32,000 as a power whose base is e. This is just like what we were doing with 24 a moment ago. This time we want 32,000 to be a power with a base of e. So Grace, what do I do to both sides? Take the natural log of both sides. Maya, what does my exponent need to be? So how about it? Any questions on today's lesson? Okay, we're going to talk about several of the homework ones together.